All right, so picking up where we left off. All right, these here are used when you have basically a linear factor. Okay, so it's not like your power functions like x squared or the cube root of x to the fifth or something like that. These are ones such as 2x plus 1 raised to the third power that you have to take the integral of, or e raised to the 4x minus 1, or ones like 1 over 3x plus 2. These are these types of problems that you're going to be dealing with, okay? And it's pretty straightforward. It's one, but the thing is, they're not on your reference book. You have to know these, okay? You all right?
No, really. You guys somewhere further back. Just back up a seat.
All right, so then in this case of these types of problems, it will be the antiderivative will be 1 over a. So for this example, it will be 1 over 2, in parentheses 1 over 4. Then you leave the linear factor the way it is, raised to the 4th power, then plus c. Yes, you can multiply 1/2 and 1/4 to get, and this will be 1/8 2x plus 1 raised to the 4th power plus c. That's how you take the antiderivative of these types of problems. Same thing applies with the next one. If I want to take the antiderivative of e to the 4x minus 1, it would be 1 over 4 plus c. Sum one up, yes? The one down here will be 1 over 3 ln of plus c. Okay? So a basically represents that leading coefficient. Again, these are linear factors. So if you had something like a 2x squared plus 1 to the 3rd power, you wouldn't be able to do these types. Okay? Only when they're linear factors. All right? So let's do some practice on our whiteboards. The antiderivative of this one. Yes, it would have been 1/6 2x plus 5 to the 3rd power plus c. Good stuff. Clear your boards. Here's the next one. Yes, it would have been 1/5 ln 5x plus 4 plus c. Here's the next one. All right, you guys, this one is nothing but a constant, so you can go ahead and pull that out, and then it's just like the other one. So you have a 6 on the outside. It would have been 1/4 1/8 4x minus 3 to the 8th plus c. This whole part right here does simplify down to be 3 over 16. Remember, you can always check to see if you did the antiderivative correctly by taking the derivative. When you multiply 3 over 16 by 8, what do you get? What do you get?
3 over 2.
Say again? 3 over 2?
And then when you multiply by the 4 on the inside, you get 12 minus 6.
You have to multiply by the inside, and then that's how you do get 6. Okay? Don't forget, this is a chain rule when you do the derivative. All right? Here's this one.
I'm an idiot. What did I do? What did I not do? I screwed up twice. 3 over 14.
Did you multiply by the
Look.
Did you divide
I
by
am
the
serious. Look me in my eyes.
Oh, I multiplied by that. I did 3 over 2 instead of 2 over 3.
Sam, not all of us
I thought I proved it right.
have to be perfect all the time to be okay with ourselves.
We don't all have a high horse.
Some of us have low horses and they get us where we're going just fine.
It's fine. Yeah, so you can't
Last
make
one.
a rise.
All right, so for this one, okay, you should have recognized that 2/3 was a constant that could be pulled out. So we would have 1 over 4x minus 5 to the 3rd dx. Now, the only issue with this is you cannot use the ln one because the ln is only for a linear factor at the bottom, not with the cube. So your only other option would have been to move it up and then work this out like the very first one at the top of those rules. Okay? So then it would have been 2/3 on the outside times 1 over a times 1 over n plus 1, which would have been a -2, raised to the n plus 1 plus c. This would have multiply it down to b, the 2's cancel out, a negative 112, 4x minus 5 to the negative 2 plus c, but no negative exponents here, so then you would have had to bring it back down to the bottom to make it positive. Does that make sense?
So the C would stay with
The c would actually stay off to the side. It's a constant. So, just that constant. Alright, questions on using these types of rules? Now the next set deals with the substitution method. Okay? Substitution method is basically when you have that chain. It's kind of like the chain rule of integration. Okay? This is when you have a function inside of another function multiplied by its derivative. Okay? And so basically, when you're doing substitution method, if you guys remember, you plug in a random variable. We used u last year, so I'm just going to still use u this year, i.e. u substitution. And you basically sub in u for the original inside function. Because when you take the derivative of it, you'll end up with the other part of the integral. Okay? So you always make u that inside function, because what you're going to end up doing is taking the derivative, which is the du, that's going to replace dx. You'll always end up with the derivative. Okay? So we're going to look at a couple of examples together to refresh your memory on how to use this, and then you'll do some on your whiteboards to see if you guys actually understand it. Okay? Now the trick is with substitution is you either want to look for the if there's e involved, you always want to, well not always, but you usually want to make your u the exponent when it's e. If you have a square root, whatever's underneath the square root, you usually want to make your u. If you have a fraction, a lot of times you want to take your denominator and make it your u. If you have anything that's raised to a power, whatever's inside of that, whatever's being raised to that power is usually what you make your u. That's honestly like the easiest way to look for things when you're doing u substitution. So when you're looking at a, you have 2x squared plus 5 squared times 4x. Now the thing is that there is no rule of any type to even try to take the antiderivative of it. And you're going to waste your time if you try to FOIL that out, multiply by 4x, and then take the antiderivative of each piece. Okay? So hopefully you can recognize that, hey, isn't 4x the derivative of 2x squared plus 5?
Yeah.
Let's see. If I make u 2x squared plus 5, what's the derivative of that?
4x.
4x. And whenever you take the derivative of u, you always want to attach the dx with it. Because what this equation turns into is the following. I'm replacing the 2x squared plus 5 with u. I'm temporarily subbing that in. The square is still there. And that 4x dx is going to be replaced with du. And it's a lot easier to find the antiderivative of u to the second than that what we had before. What's the antiderivative of u to the second?
1/3 u to the third.
It is 1/3 u to the third plus c. But that's not our final answer. The last step is to plug in u. So our final answer is going to be 1/3 2x squared plus 5 to the third power plus c. So to recap the steps, you want to look for, when you're using u substitution, you want to look for the part of the function that when you take the derivative of it gives you another piece in that original problem. And then you do the antiderivative and remember to plug you back. Questions from you two? So far, okay? This one out here, 3x squared plus 2 over x cubed plus 2x dx. Remember what I said, if you have a fraction, more than likely your u should be your denominator. If I make u the denominator, x cubed plus 2x, what's the derivative of that? no, it's the numerator. So when you go to plug it back in, you're replacing that 3x squared plus 2 dx with the du, and you're replacing your bottom with the u. That's what this looks like. But to make it more visually appealing, yes, you can write it like this. What's the antiderivative of 1 over u? Ln u plus c, and then we plug the original u back in. Questions on this one? For the next one, yep, you make u x to the 4, because the derivative of that is And to be honest, guys, anything that involves an e, you know the antiderivative of e to anything, or e to the x, or it's going to be e to the x. So you definitely don't want to involve the e at any point.
So the 4x3 just disappears?
Well, it turns into du.
So it's put back in.
So technically, it's still accounted for with the du.
Okay, but when you plug stuff back in, basically saying leave out the du.
You mean we take the antiderivative of it?
Yeah, when you take out when you plug in u, you leave out the u.
I'm not following.
Okay, what's the answer? This is against already. What's the answer?
It's just
E to the x squared.
okay.
Okay. So yeah.
Because technically, the antiderivative of e to the u is just e to the u plus c, and then you plug u back in. Questions on number 3? Number 4 still does a substitution, but it's a little bit different. Okay? What are we going to make u?
2.
With the plus 5?
Yes.
When we take the derivative of that, what do we get?
6x.
Now we're running into an issue here. Because back in my original problem, I don't have a 6x squared, I just have a x squared. But you can readjust this so that you just have x squared dx. How do I get rid of the 6?
Divide by 6.
Yeah, just do a step.
When in doubt, disappear.
Okay? So what's going to happen is when you go to plug everything in, you're going to plug in not just a regular du, but a 1/6 du to take care of that x squared dx. So what does this look like? The x squared dx is going to turn to a 1/6 du. So I'm going to have the integral of 1/6 du, and then I'm going to have a u to the 4th power. So we take care of that 6, that was originally the derivative, the 6x squared, and it basically turns into a constant. What do we do to constants when we take the antiderivative? Huh? Well, I mean, in the sense of being multiplied to a function.
Just
But
multiply.
move it out.
Move it out.
I'm lost too.
Alright, who's lost?
I lost you from the.
Okay. So let's back all the way up to the original problem. Okay? And then I'll even do this to help you out. Backing all the way up to the original problem. You cannot do this using any type of power rule or anything like that to take the antiderivative. Okay? Within one of these functions, you have the derivative. Okay? And like I was trying to mention to you guys before, I don't know if you all were hearing me, was that if you have a function being raised to a power, more than likely this function should be what you make u. So I'm going to make u 2x to the 3rd plus 5. Because when I take the derivative of it, I'm going to end up with the rest of the original function. Now, this is not exactly like the original function like how it was for all the others. Like you can see, when I took the derivative of x to the 4th, I got 4x to the 3rd. And it was already there. But in this case, it wasn't. But by doing a little bit of algebra, because this is nothing but an equation. Du equals this. So then to actually get to where it's just x squared dx, divide both sides by 6. And u over 6 is the same thing as saying 1/6 du equals x squared dx. Okay?
Question is what happens after. This is what I want.
Okay. Realize that this can be written to be like it's just multiplication. So I could really write it like this. Okay? So when you go to plug stuff in, you're replacing 2x to the third plus 5 with the u, raising it to the 4th power, times a 1/6 du. Well, 1/6 is nothing but a constant. It can be written like so. Everybody see that? Constants can be pulled out, and you can just take the antiderivative of u to the 4th, which is what? 1/5 u to the 5th plus c. What do you do with that 1/5 and that 1/6? So you have 1 over 30. I'm not going to write u in. I'm going to write 2x to the 3rd plus 5, the original u. And that's your final answer. Questions now? So, on our whiteboards, let's practice this one. What'd you make u?
3x squared plus 5x.
It's underneath the square root, so why not? What's the derivative of that?
6x plus 5.
Which is straight up the outside. So when you go to plug back in, it will be the square root of u du. That can be written as u to the. So when you take the antiderivative of it, it turns into 2/3 u
To the 3
plus c. So then you just plug the original back in, which was 3x squared plus 5x to the 3/2 plus c. If you wrote it back in the radical form, that's totally fine.
Oh, bro, I got that right. Oh, I know, actually. I just thought, I didn't think I had.
Here's the next one. You made u without the square, okay? So you take the derivative of that, you'd be applying chain rule, and then, no, too much, okay? It's just 2x plus 3 dx. So when you go to plug it back in, you'll have du over u squared, which is the same thing as saying 1 over u squared du. Now, this is not ln because it's a u squared, so you have to bring it up and then do it this way. Antiderivative would be negative 1 u to the negative 1 plus c. So that'd be a negative 1 times x squared plus 3x plus 1 to the negative 1 plus c. And you can't have any negative exponents, so then your final answer would be a negative 1. Questions on this? So your boards, here's another one. Actually, I'm gonna take a pause real quick. There's something that you need to go back and add to your notes. And then we'll go back to our whiteboard. So go back to your notes. I did forget to add this one in, or these two in. Okay? The ones that deal with your trig functions. The antiderivative of sine is negative cosine, so then it's going to be a negative 1 over a cosine ax plus b plus c, whereas this one is just 1 over a sine. These are for your trig function ones.
What about secant?
We don't have to worry about secant, cosecant. There's no going for a tangent either.
It's on homework.
There's a secant one.
Let's just cross them.
Can you just skip it?
One over cosine.
It is one for cosine squared, so.
I tried to use the photo map app for that one.
Seriously?
Nobody.
So do add these into the special cases. Again, these are not in your reference booklet, okay? And also realize that substitution method could also apply to your trig functions as well, because the antiderivative of sine is negative cosine, and the antiderivative of cosine is sine. Okay? So back to your whiteboard. Let's do this one.
Oh, great.
It's fine. It's fine.
Same thing.
Yeah. You're ugly, but it's okay.
That's your answer. We make u the square root of x, because the derivative of that, okay, bring it down to the front, subtract 1, make it positive, which is 1 over 2 root x dx. Okay, so basically, there's an imaginary 1 right here. So all of this is getting replaced with a what? A du. So you're going to have the integral of e to the u du, which is nothing but e to the u plus c